Good day to you. This is Ada Galactic on the 25th day of May, a Saturday as it happens. The old Sabbath, as I like to call it. Oh, by the way, the real Sabbath, you need to be an astronomer to know what the Sabbath is. It's not Friday, Saturday, or Sunday. That's ridiculous. That has to do with linear thinking, linear algebra. It has to be one of the 7 days because 7 is a ridiculous number. And there you go. The reason I'm wearing these dark glasses is I just woke up. I have asthma and allergies, and the dogwood is making snow in the streets. When I lived in Kiev in the late summer, it was freaking unbelievable. I did not have allergies there. I don't know why not. It looked like snow all through Kiev. It's this fluff from the dogwoods. It just rains down. Beautiful in its own way. It's not beautiful in Chico. I'm at the bottom of a bowl called Northern California. It's a desert that's filled with things that make you sneeze. So, all right, one look and then, yeah, oh my God, yeah, I just woke up too. I haven't even taken a shower, so I'm filthy. So I'm just going to talk about space-time. We're on sabbatical for another week. I am. Which means that you are too. I mean, you don't have much choice since I'm the dictator in this relationship. No, here's something for you. I'm just talking to you now. Not the professor. I'm just talking. We're just people. And I'm giving you something that you can use for the rest of your life. Does that make me wonderful and important? You know, well, that's the emperor. That's the emperor standing there, but no one's looking at his face. Which in my case is an advantage. You don't want to look at my face. Oh, God. I don't want to look at my face. All right, let me collect myself here. Space-time, my goodness. Men have lost their minds, literally, or figuratively, however way you want to look at it. But they've lost their minds. Your physicists have lost their fucking minds. Because space-time, oh my God. John Archibald Wheeler, Nobel Prize winner in this field, wrote a book called Space-Time. Oh, I meant to get that book off my shelf to show you that I actually own it. And I read like about a third of it. It's just a little girl. It's little Johnny Archibald Wheelerette just writing in his little pansy colored notebook. Space-time is so beautiful, it makes me sing and feel such joy. And then every single one of these deluded men say, oh, space-time is curved, children. Space-time is curved. Oh my God, this is better than the religious, superstitious people talking, isn't it? Space-time, oh, it's so magical. They literally don't know what they're talking about because Einstein, you have to understand what Einstein was looking at back in 1905. So let's wind back the clock a little so you know that I'm not just making this up. And what is it? I'm getting to it. I'm not going to give it out the gate. I like to build up to a climax. I know, but I don't make the rules. I just follow them. So what is space-time really? Is it real? Well, you have to go back, first of all, to see what people thought about space before Einstein. Now, time is the lacuna. The lacuna, yes. Most of my American audience is not going to know what lacuna means. And I just turned on my browser window to show you something, but I'm in the development phase using my new software. This is a brand new version of OBS. It's just completely different than the previous version, but it's the modern one, the up-to-date one. So I lost all of my capabilities once I upgraded. Nothing works now, it's just except the basics. That's why you don't see any introduction. There's no music, there's no hog sounds, there's no titles. It just starts out like today. Now that's all going to change in June. I'm gearing up. There's one more week, and I'm gearing up. I got 90% of everything all set. Now live streaming, one of my commentators, actually the only one, pointed out that I should be using 30 frames per second. I know, but the new version of OBS comes preset to 60. And I have to go back and change everything again. This is what happens in software. So what did people think about space? What did people think about time? I was going to show you the meaning of the word lacuna, but I can't show you. But I'm going to look it up just to... because I don't use this word exactly correctly. I use it in my own way. Okay, actually, according to Oxford, a lacuna is an unfilled space or interval, a gap. That's exact. Okay, I am using it right. Well, it surprises me. I have a tendency to remember a word that I find useful, a little unusual word like lacuna or dichotomy, and I alter it to meet my needs. Well, that's actually a little bit unscientific to do that, since everything in science is based on communication. It's a major issue in science to get the right words for things, which is a collaborative and consensual effort, a communicative effort. Now, we're talking about space-time, which is already a pretty strange word. Space-time? Before Minkowski came up with his linear formulation of space-time, which he basically gave to Einstein as a present, well, where did Minkowski get it from? He got it from the then less than a century old, is only like 70 or 80 years old, called non-Euclidean geometry. Well, as we discussed over the past couple of, I'll just call them informal presentations, since that's what they and this are. Space-time is obviously a conflation, which is a term from linguistics meaning to combine two things. It's a conflation of terms. So space-time already, I mean, that term should not be used. Space-time is a confusing word. What is it actually? Well, it's actually a reformulation of space. Nobody has ever figured out what time is. I have. It jumps out at you when you finally get the metric for spherical space. Two things jump out at you. Well, three if you count light speed. But in the spherical formulation of geometry, the very first geometry except for the Euclidean line. When you say Euclidean, you're saying linear. That's all Euclidean means, which is also a source of confusion. The whole thing is confused because physics is confused right now. You may say, no, it's not. We're in outer space and we have lasers and reactors, so we're not confused. We're on Earth, darling. Just remember where you are. We're using Earth mathematics, okay? But it is remarkable, since linear space, as I proved in 2022, the linear number system, linear geometry, is embedded in a higher order space. Spherical space is inherently bigger than linear space. You could say by approximately 6.28, by a factor of 6.28. It's that factor of 6.28, which when you drill down and you keep, then you zoom in and you keep drilling down to get to the center of the atom or the center of the proton. The center of force is what's being sought in subatomic physics, although not anymore, nobody cares. All they want are those goddamn particles. I believe there's officially 26 particles now. It's total nonsense. What those are linear derivatives. They're actually the flotsam that you throw off the back of the boat. That's what gluons and pions and muons are. They're things when they shatter two protons together in a collider, all kinds of shit flies out. It's like taking two Swiss watches and smashing them together, by 1,000 miles an hour. Such as Destin of Smarter Every Day might show you. I don't want to get off on a tangent here, although we are on sabbatical and I could. Space-time. What is it? It's a reformulation of space. The first reformulation of the definition of space, the axiomatic definition of space. So we're talking about the absolute dead level bottom line of science itself. Space, yes. Time is something that's always thrown in. It's per second, and nobody's ever defined a second. Nobody knows what a second even is. So we just give it a name, time. And it was always considered to be continuous. So is space. All physicists, before Minkowski and Einstein, assumed that space is continuous. It's not anymore. Although, I'll show you that it actually is. It would have to be continuous, for Christ's sake. Time is continuous, it's not quantized. Well, it is in space-time. It has to be because space is quantized. The reason it's quantized is because it's Euclidean. Linear. You can only give a null value. Any number on a line is null. It has no meaning by itself. It only has meaning in relationship to 0, which is, we're getting there, but that is not a number. I'll just say it this way. In the derivative number system, which is the Euclidean number system, Euclid did not realize that he was dealing with a number system, and it took about 2,000 years before it was fully realized that Euclidean geometry is exactly the same thing as linear algebra. Linear algebra and Euclidean geometry are precisely the same thing. What does that leave out? It leaves out a dilation factor of 6.28 ... which is the number of irrationality that defines the relationship between linear and spherical space. Technically, in spherical space, it's 2 tau. But on the circle, the relationship between the radius and the circumference is 6.28. But that's a linear number, and it's null. It actually has no meaning in the system, because none of the numbers have meaning. They only have, they have one meaning, exactly one meaning. The number system that we're taught in school and has been taught for centuries now, the only number system besides the complex number system that we have, is composed of numbers that all relate to 0 because that's the central number. It has to be there or you can't get the metric for your space. And once again, as I'm going to drill into your head because I'm your professor now, linear 0 is only there to cut off the line on one side so you'll have positive and negative. Basically disregard the negative and just concentrate on the positive because all distances are positive. Unless you talk to the particle physicists, oh no, everything can be reversed. Time can go backwards. Don't listen to these men. They're out of their fucking minds, okay? They really are. So what is space-time? You can't expect a very fast answer because it's going to be too cursory. It's going to miss the details. You won't understand. But if I told you the whole definition of space-time, elaborating every single point, it would take hours. Now we need a happy medium so that you can take this home. You can share it with children. You can tell them what this stuff means because you actually know. What is space-time? Well, here's the story in a nutshell. In the 1830s, I'll just say the mid-19th century is what 1830, 1840, 1850. A lot of stuff happened about then, all centering on the magic year 1844. Sorry, I shouldn't have said that. And space-time came about as the result of non-Euclidean geometry. Now that's a misnomer. There is no such thing as non-Euclidean geometry except here at Anagalactic. Now the rest of physics does not know about my research. You could say you're privileged, or you could say you're a cat on a hot tin roof with this mad professor from the wilds. It's very simple. It's even simpler than Euclid's definition. I gave that to you in the lecture before last, although it's informal. It's the first time I ever laid out a Euclidean beginning. To replace Euclid. This replaces Euclid. Now, first of all, get something out of the way that I've covered so many times, but it's critical to have this in your head. We don't lose the linear number system. We can't. We mustn't. It's impossible. Euclid was right. He was following the blueprint. It's just that it's been 2,500 years, approximately, for mankind to have evolved. There is evolution. It only pertains to the human race. Only the human race evolves, and it's not genetic. It's scientific. It's logical. What's the purpose again? Okay, your emotional side is for love and all the other emotions like joy and fun. None of it's rational, but it sure is a big part of life, like 99%. Well, that 1%, it's for your other subsystem, your logical subsystem. That's not an accident. That's not something we developed on the African savanna while we were changing from chimps to apes to hominids to Homo erectus to Homo pithecus to whatever they make up to get rid of the notion of creation, which is the only scientific view of the ecology, including humans. The purpose of the rational subsystem is to give you a system of thinking to fight against lies. Because all the shamans, I mean our physicists today, the shamans of today are the physicists, they are professional liars. It's their job to lie to you. That's what the government wants them to do. Do not let the people have any conception of their origins or have any notion of what you're actually doing. Which, if you knew what the physicists are actually, if they knew what they were actually doing, the only logical course for them would be to slit their own fucking throats. They don't know what they're doing. Okay? It's really that simple. The physicists have lost it. It's space-time that did it to them, and then the quantum mechanical paradox sealed the deal. They're all in Bedlam now. Bedlam, by the way, is a state hospital in New York for the insane. That's what Bedlam is. So it began with Lobachevsky. Lobachevsky was a Russian mathematician, was probably the best title for him. And he discovered what he called non-Euclidean geometry. Now, it's not non-Euclidean. The reason why Lobachevsky, and to complete the thought, is also a man named Bolyai Janos, whose father knew Gauss, and Gauss communicated with these two men. So Gauss was in on this. And Gauss probably truthfully claimed when he heard about this new non-Euclidean geometry, he said that he'd already figured it out in his head. He just didn't want to publish because he didn't want to be ridiculed. That's what he said. Now, mathematical historians have wondered whether Gauss actually, there's no proof, is that we only have his word for it. But the Bolyai contingent in Romania, when they heard this, they believed Gauss. Gauss was the man of Europe at the time, one of the greatest mathematicians of all time. He's been ranked as about a tie between Gauss and Euler in a certain camp. You know, this is the beauty pageant contest. Who's the greatest mathematician of all time? It's a human question. We just love to do this. But the Bolyai kids, father and son down in Romania, when they heard back from Gauss, and Gauss said, "Oh, yes, I've figured this out already, but I haven't written it down." Oh, they knew Gauss wouldn't lie to him. He might have been. Well, nobody knows or cares now, I don't think. But it was the beginning of non-Euclidean geometry, so-called. What was it actually? Well, it was one more re-examination of Euclid's parallel postulate. One of the most amazingly persistent motes in the eye of scientific history has been Euclid's rather admittedly baffling inclusion of the parallel postulate, which has to do with infinity. Because if two things are parallel but they just go off forever, do they ever meet? Answer that question in your mind now. Well, obviously they don't if you say they don't. But infinity is just, it's imaginary. Maybe they do meet. Well, if they do meet, those two parallel lines meet at infinity, that's called projective geometry. And basically it tries to get the center of the system, and it puts the center of the system at the edge. It's called the point at infinity. One of the most remarkably nonsensical statements that's ever come out of the mind of man is the point at infinity. Now, we're not going to get into that grotesque detail. What I want you to understand to begin with as we approach the concept of space-time, which is a 20th century concept, it began with Bolyai, Gauss, and Lobachevsky, each of whom, one simply by claiming so, Gauss, but we'll believe him and say that he did too. The three of them, essentially simultaneously, one of these strange aspects of human evolution, which is scientific, as I just mentioned, is that when men receive a vision from on high, or how the pixies talk to them, or however you think their brain synapses just suddenly recongealed according to the Big Bang, and now their plasma is doing this thinking thing. Well, the parallel postulate is considered to be responsible for this fixation that there can only be one geometry. But if you say that the two lines that are parallel to infinity actually meet, that's called non-Euclidean geometry for that reason. And there's two different ways that the two lines might either meet or not. If they converge, that's basically called elliptical non-Euclidean geometry. Basically. This is a very rough sketch. But if they diverge, hyperbolically, the two lines just go off and diverge, that's called hyperbolic non-Euclidean geometry. They are still Euclidean, though, if you define Euclidean the correct way, which is simply you're using lines. Well, they continued to use lines. What they tried to do was bend the line. And I have a whole lecture on that called Understanding the Dirac Equation, where I talk extensively about this misconception. So there is no non-Euclidean geometry for the simple reason that you're still using lines. And what they tried to do with non-Euclidean geometry was develop a consistent Euclidean-like axiomatic basis where the parallel postulate is denied. And that's how it's given in all the textbooks. I consider that to be a baffling and insufficient explanation. But it's due to the fact that everybody is so fucking confused. Because beginning in the 19th century, really the second half, humanity encountered the sphere. It's so simple that it doesn't sound like that could possibly be the reason. Because it's too simple. It's like, how could it be that simple? How could our physicists be that, blind? Well, because they have their problems dealing with what they were given by their predecessors. Okay, that's 26 minutes. I'm going to take a break. I do have to take some medicine and take a shower and get ready to speak. But in a little while today, the 25th, I'll have a lecture on space-time where you'll finally understand it. So stay tuned, and we'll be right back.